So today I promised we'd do the Maxcom 7E walkie-talkie Wednesday, and although this is an emergency set, it can be used as a walkie-talkie, and we are intrigued as to how well that works. So what do we get? Oh, I've actually got 4 of these, and I've bought 4 just to be able to make up one full kit, because every time you buy one of these something's missing, and that's not the right rubber duck. So that doesn't look like the right rubber duck. So we'll start by concentrating on the radio. You get a magnetic aerial. For some reason we've got 2 dummy batteries, and it's actually 1 for these. So usually you end up with no dummy batteries. Cigarette lighter lead. Tell you what, we may as well power it off that. We'll save faffing about. Little mag mount. Telescopic aerial. And you can either use it on the actual radio, there's a screw-in fitting there, or on the magnetic aerial. And on the back of the radio, the carry case is also a battery pack. So I'll do a bit of cleaning up, and it's 10 rechargeables or 9 and a dummy battery for throwaway batteries, because the radio is 13.2 volts. Yeah, it's 10. So we'll get it out of its nappy. Oh, the radio's gone over to, the background music system's gone over to radio, like happens. I've got a builder here changing a bay window, and I've got to keep an eye on the time because I've got a shopping job to do for one of the elderly parishioners. The camera's moved itself. The camera doesn't live on this angle. How's that? Must be all these RAF jets going overhead. So we'll plug that into the cigarette lighter socket on the bench, switch the power supply on, and to 13.2 volts and not 13.8. There we go. So a very versatile set. So it can be used as a walkie-talkie, it can be used as lots of things, because you've got the external aerial socket here, high-low power, which I've just found so useful, and since 2781 was replaced, and it hasn't been a legal requirement to put high-low power. When you're in a convoy, and you know you've got 3 of you all in cars, and you all end up stuck up at traffic lights to get to, you end up with too powerful a signal, and unless you've got RF gain, it's kind of going to go into feedback. Whereas if you're all on low power, it would work so much better. Anyway, I've printed off from the instruction book that I previously have scanned looks like the colour cartridge is wanting replacing. It also says that it will do less than 1 microvolt sensitivity for 20 decibel cyanide, which I somehow doubt. They're reliable. Well, I think all the Maxcom sets are reliable. They're never the most outstanding performers, but they're reliable, and they're not rubbish performers like the Fidelity 1000 and the Great Series radios that we're doing on Sierra Hotel 1 Tango set Sunday. Now, has this got some crack damage? Has it been glued together there? Not really, doesn't matter, but I think, oh, the front comes off this. Tell you what, we'll put it to what we think is channel 20, make it easier later on. And there we are, managed to get it off. Yeah. So we're left with an Electret condenser mic and a full-size loudspeaker, with a decent sized magnet and voice coil on it. You know, a lot of the new mobile sets haven't got speakers this kind of size. No wonder they sound so dreary these days. This doesn't look like it's ever been touched. And I'll get this connected up and we'll work our way through it. So we could do the VCO because it's in the instruction book servicing bit, but it's clearly, you know, if the thing's transmitting and receiving on 40 channels and it's never been touched, I don't think we need to go into this. But the test point is actually resistor 55, because I can't see anywhere that says test point on the radio. The resistor 55 is down there. Then it will be coil 1, which I expect is the one with the wax in it. Yeah, it is T1. You're on channel 40 and you're looking for 3.2 volts on channel 40, and that's in transmit. Then in receive you go to channel 1 and you check that you're between 1 and 2 volts on that test point. So really, as long as it's usually between 1 and 4 on transmit and receive over the 40 channels, that's about where it should be. So we're not going to do that because it's unnecessary on this one unless it proves to be faulty. So we're on channel 20, but this radio isn't on channel 20. You saw me put it on channel 20. Let's see what it's on. It's channel 19 we're on, so we need to go up one more click. I bet this has been discarded because all the channels are out of kilter, but of course the knob's been pulled off and it's been put on in the wrong position. So that's channel 20. Now we've knocked it up one, good buddy. So we're going to go through L2 to L5. So we start with T4. If I can find where they've even labelled any of this. Yeah, right. That's about as much use as a chocolate teapot. Right, so we'll select the other camera. Oh, not that big. Sorry about the builders bashing about and shaking the camera. And so at the moment we're just a whisker away from 3 watts, so let's see whether we can bring that up. So that's the same. I'll put the soldering iron on ready to melt the wax out of the next coil. Ah, there we go, that's now gone beyond 3 watts. So that's the peak at 3 watts. That's had a wrong screw. Yeah, it's been dropped on it and broken the switch away, which has been repaired. If I've got an ordinary screwdriver, we might be able to tighten that up a fraction. Okay, so we'll move over to L whatever it is. Needs a bit more heat. And 3.1. you know, I've never seen a Maxcom 7E before. Well, on the bench, I mean. So it's capable of about 4.4, so we'll just turn it down to 4. It is a bit warm, it might be developing more than that when cold, which we'll check that later on. In fact, we'll just check it again now. Yeah, it's just under, so that's alright. So I'm going to switch to low power. So it should be 0.4 of a watt. It's 0.15. Is that adjustable? They want you to turn it down to 3.8 watts. We've actually set it to 4. No, the low power isn't adjustable. So we'll switch it back to high, and we'll do the deviation. So put the oscillator against the microphone there. Go into transmit. That is 2.1. Just do a quick whistle test. 1, 2. It's spot on. Absolutely spot on. So to adjust the deviation, it is RV2. And RV2 is that one, which on the radio is just there. So you've just got that coil, which is T3, and just as a bit of wiring, and it's just down there. So luckily we don't need to touch that. So I wonder what RV1 is. Quick look at the circuit diagram. Oh no, it's Squelch, it says. So now we'll check it's on frequency. So I'll just move the camera across. It's a bit quicker doing these when you haven't got a S meter. Okay, so we should be looking at 2779.125. 2779.110. It's slightly low, so we just need to pop the frequency up a little bit. So it's the red preset in the corner. And whatever I do, I'm bound to turn it the wrong way. I did. There we go, 2779.125. Just toggling 6, that'll do us nicely. Oh, just for your information, it's 80 milliamps on receive, 910 milliamps on transmit. So we're covered, we're done. I've got my looking at the time, I've got 20 minutes. We'll look at the receiver. The first thing I'm going to do, I'm going to look at the detector. So we're looking for better or greatest amount of recovered audio, and so just looking for the detector coil now. And it's going to be that one or that one. Let's see whether I've got a clue in the circuit diagram. Looks like it says T5 or T6. It print's so small I can't even see it. Let's see if I've got anything in the instructions. T8 is maximum audio recovered, it says. So T8 is that one. do that first. That was pretty spot on. It's one of the things on Maxcom sets that can actually go out quite regularly, but on this one, not so. Okay, we'll go over to the cyanide meter. We'll see what we're doing on set on that. We'll pop the bench light back on. So at the moment, let's get my notepad out. Maxcom 7E. So we're going to do 20 dB cyanide, 12 dB cyanide, 10 dB cyanide. Manufacturer says it should be greater than 1 microvolt. So we'll see, because I don't believe that for a moment. So as it's come, we'll do the 12 dB for as it's come. As it's come, it's 1 microvolt. Right, we'll see if we can improve on that. So we'll drop the attenuator. It says T5, 6 and 7. 7, 6. Must be that. The one that's not labelled. Five. 6. Wow, that's made an improvement. Perhaps somebody's had it in to be tweaked down. We get a lot of radios that have been tweaked down. There we go. And there's no distressed looking capacitors. So let's get a new reading. I mean, that's all aside. We normally can hear 0.3 of a microvolt. Well, I can't, you know, so it's not, I don't think it's the last word in receivers. Okay, let's get that 20, we'll start with that 20 decibel figure, and we're getting 2.5 for 20 decibel. So I knew that was going to be bull. So we'll go down to 12. And we've now got I think we can go on to the other scale actually. We've now got 0.9 of a microvolt. And for 10 decibel, .75 of a microvolt. So yeah, there's an improvement. And that's it. There's nothing more. Oh, Squelch, there is. Okay. So I'll move the camera onto the attenuator controls, and then you can watch me check this out. There we go. So we'll turn the we'll set the signal generator for 0.3 of a microvolt, and we'll turn it off. So we're off. We'll set the squelch to threshold. There's threshold, and we'll switch the signal generator on, and we get nothing. So let's increase the signal till we get the squelch. So we've got it at 1 microvolt. So let's get to fine-tune readout. It's coming in at 0.65 of a microvolt, and it's leaving it 0.52 of a microvolt. So that's fine. That's going to do scratchy corner just fine. So now we'll turn the squelch to full. So there we go, full. And so we'll see when it comes in now. I want it to be less than S9, S9 being 100 microvolts. So that's 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts, 300 microvolts, 1 millivolt, 3 millivolts. And that's another thing which is useless as a chocolate teapot. So with RV1, yeah, it's definitely been fiddled with, hasn't it? It's the preset just down by the PTT switch. So I've now got the signal generator on 100 microvolts. I need to just advance this until I can hear that. It's actually dirty. A quick spray of Servicol 30, and we'll work that around. See whether we can get it just so. It may be a compromise. Just comes in. It's about, yeah, it's about, it's not S9, it's about S10. Let's see where it is at the other end. Turn it back down again, switch the signal generator off. Set threshold, do that test again. 1 microvolt. Coming in at 0.7, it's leaving at 0.52. That's fine. So that needed looking at. So between that receive coil that had been messed with and the squelch that had been messed with, the transmitter didn't appear to have been touched. It was just doing 2.9 watts. It looks on this occasion that the receiver had been messed with. So we'll put that back together and we'll just pop it onto the aerial. Sounds like we're getting better sensitivity now. It's get cases on. I'll pause the video. So it's May 1982, made in Korea, and I think they made loads of these. They seem to be very popular, and I think they were £79.99. So considering what you could do with it, was good value. The only thing it missed was the earphone socket. So we've had to set the test equipment by putting a crocodile clip onto the speaker. So what we'll just do, we'll change the aerial over, and I'll just put it on. We'll just widen that out a bit, and we'll just put it on the roof aerial instead of the test equipment, and just see whether there's any good budgies out there. Somebody says, what aerial do we have here? It's a really basic Antron 99, and this is a single-story building, and it's mounted 4 feet above gutter level. So it's on a wall bracket. The pole goes down to the floor for best stability, and it's just 4 feet above the, so the local ground height, we're probably only looking at about 4 meters from the ground, and it hardly pokes out above the top of the bungalow. Only the last couple of feet of the aerial do. We haven't got the optional ground plane kit because I wanted this to be as these tests to be as repeatable for other people. There's nothing special, and the cable is ordinary mobile type feeder, but it is that industrial one we use, which we get from RS. Oh, I've got to put the knobs back on. That would help. I don't see any reason we've got to put this one through the dishwasher, but I will need to clean those contacts. So just make sure that's in the off position, and we'll put that knob on. And we'll put that knob on, and we'll carefully make sure that the channel knob is actually on channel 20. Because without an LED readout, you haven't got another chance, have you? Okay, here goes. One and a Roger. That never works. Well, I love living in the middle of nowhere, half a mile from the nearest neighbour, and 7 miles from the nearest anything, and 35 miles from the nearest city. It really suits me, and it's not bad for radio traffic. Right, so we'll put that to one side, and we'll just look at this carry case, wherever I put it. I'm looking at the time, I've got 1 minute. That power supply, not only repairing one which I'd bought already working but needs overhaul, certainly, like the capacitors changing, but I'm going to be building one from scratch exactly the same. Mr. Chippy's done the artwork for the printed circuit board, which is a matter of taking all the components off the existing circuit board, photocopying it, and then he imported it into one of these paint type programs, and he filled in all the tracks as black, and all the where there shouldn't be tracks as white, and so we've got a really good master, and I've been waiting for acetate material to have come suitable for use with an inkjet printer, because we've found it works better with an inkjet printer, believe it or not, than it does with a laser printer. We're using a photosensitive PCB technique. We're not using the toner transfer technique, which I don't get on with and waste too much time. But I'm going to be showing you 2 ways of doing the printer. I'm still looking for this case. I'm going to be showing you 2 ways to do printed circuits. So it's all well and good, like we have equipment to make printed circuits, and I can churn them out in 20 minutes from start to finish. But you also need a kitchen table method. There'll be limited space here. Whatever we do here is kitchen. Right, we'll pause the video while I look where I've put the case. There we go. So what we've got is a situation where we've got a little bit of corrosion on that bottom battery. And if I can find the fiberglass brush, which is red on this bench and white on Mr. Chippy's bench, we'll just go through these contacts and just make sure that they're clean. Especially that one. There we go, that looks better. And we'll put one dummy battery in. these are the dummy batteries that I think came with Harvard handhelds. Of course, these radios didn't come with dummy batteries. They expected you to put rechargeables in. Right, so we'll do an on-the-air test later on, and then subsequently, when we've got time, we'll be doing a field test with this as a walkie-talkie. We've still got the realistic 1005 to do, and that will get done when time permits and weather permits. The only occasion we had time, it was pouring with rain. So there you have it, the Maxcom 7E, in this case from 1982. Thank you for watching.